back to Homework Help with Miss Core. Today we're talking about our Unit 9, Day 5, solving quadratics by our best method. So remember that sometimes there's going to be an advantage to using factoring. Sometimes it'll be easier by just taking a square root. Sometimes we're going to complete the square, and as always, you can always use the quadratic formula. Unfortunately, sometimes that's the more tedious way of solving my problem. So when I'm taking a look at number 1, I want to decide what is the best way that I could solve this one. So I'm going to take a look, and I'm noticing that there is no b term. My b is 0. If I divide by 3 on both sides, I end up with x squared equals 16. That's telling me that I want to take a square root as my best method. Taking the square root of both sides, I get x equals plus or minus 4 as my roots. Now taking a look at number 2. Now number 2, there is a b term, right? There is a b term, but I'm missing my c term. So I'm asking myself, all right, can I factor this equation? Well, I certainly can. There's a GCF of x. So I have x times x minus 5 equals 0. So this time I'm using my factoring method. I'm then going to set them both equal to 0. And my roots then are 0 or 5 as my solutions. Taking a look at number 3. Number 3, I'm looking, I have a trinomial, so I'm not going to be using my square roots. I'm looking and I'm thinking about, can I find numbers that multiply to 15 but add to negative 2? Oh, I certainly can. So I am going to try to factor this problem. When I factor this, I'm going to end up with x minus 5 times x plus 3 equals 0. I'm going to set both of them equal to 0. And I'm going to solve both sides of my equation, giving me 5 or negative 3 as my possible roots, my possible zeros. Skipping ahead to, let's take a look at number 6. Okay, so number 6, I'm looking at this and I'm looking at what could be my best method to solve this. So I can think about factoring it, and I can first think about factors of 18. Are there any factors of 18 that are going to add to negative 2? With a quick thought, I realize that nope, I cannot find any factors here. So I am typically going to jump to either completing the square or to the quadratic formula. Now I am going to steer clear of completing the square because I have a leading coefficient of 6. So I am going to use my quadratic formula to solve this problem. That would be my best method here. Let's skip down to 9. Okay, question 9. So in question 9, the first thing I'm going to ask myself is there a GCF? So I'm looking at all 4 of my terms here, and I'm going to factor out a GCF, leaving me with an x to the third minus a 5x squared minus a 9x plus a 45 equals 0. Now, I have a problem here. I have too many terms for my quadratic formula. I can't do it. So what I'm going to do next then is I'm going to think about how can I, if any, can I factor this problem? So over to the side, I'm going to make a little box. And since I have 4 terms, I'm going to fill in all 4 terms into my box to see if this is factorable or not. Now that I have my box made, I'm going to factor out my GCFs. So I have an x squared, a negative 9, I have an x, and I've got a negative 5. So now I have x times x minus 5 times x squared minus 9 equals 0. Now looking at all of those terms, I realize, oh, wait a minute, this one can be factored again. So I have an x times an x minus 5 times an x minus 3 times an x plus 3 equals 0. Now I'm going to break up all of my roots here. I have an x equals 0, x minus 5 equals 0, x minus 3 equals 0, x plus 3 equals 0, giving me solutions of 0, 5, and plus and minus 3. Let's take a look at question 11. Writing the following infinite sequence in explicit and recursive forms. So the first thing I have to decide is what type of sequence is this. So I look at my pattern, 2 to 4, 4 to 6, 6 to 8. This is an arithmetic sequence. So if I want my explicit formula coming right from my reference table, a sub n equals a sub 1 plus n minus 1 times d. I'm going to fill in all of my blanks. That is for my explicit formula. For my recursive formula, I'm going to start with my a sub 1 value, and then I'm going to fill in my a sub n value using my a sub n minus 1 term. Number 12, when I'm looking at this pattern, I'm noticing that I go from 2 to 4, 4 to 8, 8 to 16. Well, that is a geometric sequence. And again, pulling my formula straight from my formula sheet, my a sub n equals a sub 1 times r to the n minus 1 for my explicit formula. And you can fill in the blanks there. For my recursive formula, similar to before, I'm going to state my a sub 1 value. I will then give an a sub n value in terms of my a sub n minus 1. Hopefully that sends you on your way.